Hello everyone, my name is Angel Enriquez. I am CEO of Emboa Medical. And today I have some unfortunate facts to share with all of you. And that is that ischemic stroke is a devastating condition. This is when there's a blood clot that stops blood flow into a major brain artery. And once that blood stops flowing, the clock starts ticking. This is where the notorious phrase of time is brain comes from. Every 40 seconds, someone suffers from this type of stroke. That's almost 800,000 Americans each year. Not only that, Black, Indigenous, people of color are 2 times more likely to suffer from first-time stroke when compared to white adults. Every minute in this lack of blood flow state, 2 million neurons die. This is the equivalent of aging 3 weeks per minute or 3.5 years for every hour. This could mean losing your ability to walk, talk, or even sustain function. Stroke is not only significantly impactful in mortality, it is also an immense contributor to the United States healthcare costs. Luckily, surgeons have tools at their disposal to be able to remove the blood clots causing stroke. Here are 2 strategies and the therapy is known as mechanical thrombectomy. Here you have the stent retriever, which is a tiny metal mesh tube that is able to physically interact with the blood clot and physically remove it. Unfortunately, though, it has a high complication rate. And then you have an aspiration catheter. It's faster, safer, and more cost-effective. Yet, when interacting with a blood clot, it has a lower force. Let's take a closer look at this. So here you're seeing that in order to have a successful thrombectomy or blood clot removal, the aspiration force needs to overcome the friction between the blood clot and the blood vessel. Now, unfortunately, as you go deeper and deeper into the brain, these vessels get smaller. Therefore, your catheter is smaller, and that significantly impacts the force. And so you see time and time again that as you go deeper into the brain, these catheters are less effective. Emboa identified this as an opportunity to innovate in the field and has developed TRAP, or the Thrombus Retrieval Aspiration Platform. Here, we're using bio-inspired design to engage with the blood clot at a different way. Now, there is an additional force that wasn't available before, and it's independent of the catheter size. And so here you're seeing our proof of concept catheter of a polymer with rows of clot trapping structure to better able to grip onto that blood clot. Now, we see this as a huge advantage for a space in the field that still hasn't been addressed. This is known as medium vessel occlusions. So this region in the brain that is much smaller than the larger vessels. And these are up to 45% of ischemic stroke cases, yet there is still no preferred treatment strategy, and there have been 3 clinical trials recently published 2 months ago that state this fact. We've been able to quantify the advantage that our proof of concept provides when compared to a conventional smooth inner diameter catheter and achieve 3 times greater force. To put this into context, we're easily able to lift this 50-gram weight, whereas the conventional smooth inner diameter catheter cannot. One aspect that surgeons want to achieve when they're doing this surgery is being able to remove the blood clot causing stroke in the first attempt. That's less time being in an ischemic state, right? So here we have a physiologically relevant model, a patient-specific silicone model, and we input a blood clot, a very stiff, challenging blood clot, and we've been able to provide that the TRAP catheter has a 100% first pass effect rate in this worst case scenario compared to the controls 70%. Now you might think that this increase is insignificant, but if you think about it in terms of saving lives and making sure that the patients are having a functional outcome, it's quite substantial. In the competitive landscape, Emboa is uniquely positioned to provide higher blood clot removal force and lower risks when compared to a stent retriever, but higher blood clot removal force when compared to aspiration catheters. The thrombectomy market is rapidly increasing with a CAGR of 6.8%. We have established CPT codes, MSDRG codes, and a projected price comparable to competitors. The total thrombectomy market is huge, and we're tackling the neurovascular as a SAM, and then further than that, we'll target the medium vessel occlusion market. I would also like to highlight other company exits in the space where larger medical device companies continue to acquire startups with novel and disruptive technologies. Additional to this, we're not limited by neurovascular application. We can also apply this to pulmonary embolism space or the deep vein thrombosis, which also use this type of procedure to remove blood clots. Our go-to-market strategy, as I mentioned, we're targeting that MEVO, the small vessels. Our competitive advantage is the higher forces at that smaller scale. Our customer are those hospitals and stroke treatment centers that have neurovascular stroke centers. Our market penetration strategy are having that KOL feedback, publications, conference presentations to kind of drive that adoption. Our funding opportunities include government grants, pitch competitions and investments, or a potential future partnership with an acquisition. And our regulatory pathway is quite straightforward with a 510(k) clearance with established predicate and alignment with the CPT codes. Our team is uniquely positioned to take this technology to the next level. This was a passion project of mine during the PhD, and I had a plan to become a professor, but I since sidetracked that to get this technology to commercialization. There are 2 neurovascular surgeons in our team with more than 30 years of experience, having already co-developed and commercialized other neurovascular products, and our CTO is a medical device research expert, being successful in other ventures as well. We have gained significant traction in the last year and a half that we've been operating. We have a provisional patent that was filed in February, converted to PCT early last year, and a freedom to operate report from Wilson Sonsini. This is our product roadmap. We foresee having a 510(k) clearance by the end of 2027, early 2028, with established milestones as seen here. And so for our next steps, our milestones are finalizing a preliminary in vivo study, design for manufacturing, so freeze the design that we currently have a conversation with the FDA through a pre-sub, and continue to add to our patent portfolio to strengthen our IP position. And so our ask, we want connections with patent lawyers to help with this broadening of the patent portfolio, connections to interventional radiology surgeons, as well as any finite element analysis experts or connections for investment. And with that, I thank you. The market seems small. Is 2 billion small? Well, I don't agree. In the tens of billions? No, for thrombectomy, that's the market size. If you're talking about biologics and therapeutics, maybe the margins and the prices are much larger. But for devices like this, that's generally where the market is at. In the medical insurance for... Yes, so not necessarily talked, but it's openly available information. There are already established CPT codes for this procedure specifically, and MSDRG codes for treating ischemic stroke. And so we would fall within that established terminology. Yeah. Thank you for that question.
So I think you alluded to this a little bit, but what is the business strategy? Is it to grow? Is it to get acquired? Who are the key strategic partners? What is competition in this space?
No, great question. So the question of business strategy, we really want to establish differentiation with the type of design we have and strengthen our IP portfolio so that we can either get acquired or license our type of technology to a strategic. The field is quite saturated, but the aspect that we're introducing, as well as the target market that we want to commercialize in, has not been fully addressed. So that's kind of the goal, to show that differentiation and hopefully get acquired.
I want to ask one more question. So you grab onto that clot. What are the chances of the clot breaking versus actually releasing, its hold on the vessel? Is that a danger? Do you create potential complications that way?
Yeah, no, great question as well. So it really depends on the type of clot. It's very heterogeneous, and really this type of phenomenon where the clot becomes corked at the tip happens regardless of having the structures there or not. We're just enhancing the forces available to current catheters in the market. And so it doesn't necessarily increase that chance of fragmentation, but if it was already there, it was already there.
Can you say anything about the bio-inspired engagement with the clot?
Definitely, definitely. So it's a very interesting area. So if you look at a boa constrictor's teeth and compare it to a shark tooth, the shark tooth is very triangular in shape, very spear-like, whereas the boa constrictor has that curved type of profile. And there's a purpose for that. So shark are trying to chomp through their tissue, their prey, right? Whereas the boa constrictor is trying to trap it. And there's stresses involved in that. There's a higher peak stress with the sharp edges, whereas with the curved, you're distributing it all across that surface. And so we're trying to take advantage of that concept into our structures.